Our experiment is on managing traffic load in NDN routers by managing the PID size. PID size, what is it? PID size stands for pending interest table. When a content is unavailable, an interest packet is added to the PID until served by a matching content. If PID entry is present in the router's memory for a long time, it gets dropped off from the router. Why to take PID size as a parameter? If PID size is less, client needs to retransmit the packet from time to time. But if the PID size is more, client need not retransmit the interest from time to time. This PID size is in indirect correlation with latency. So in our experiment, we have utilized different PID sizes to gather performance metrics. Even though we have got very little change, in practical applications, the change may translate into very significant in magnitude.
We have used a simple topology to experiment the given project. Our topology consists of a data source, router, and two nodes. We modify the CCNC software for configuring different page sizes and generate the binary file and upload it to the router.
Here we have a slice in Gini and we upload an RSpec file from our desktop. As you can see, we have four nodes here: a data source, router, node 1 and node 2. From the data source we request the data and node 1 is the one requesting the data, which passes through router. You can see that we are using Stanford IG for reserving the resources and click on reserve resources. Now we can see that our resources are allocated in Stanford IG. We use the ready to login command to see the status of the nodes. We can see that everything is ready and we get the SSH login command from this window. We try to log into the node 1 using the SSH command from the window. Similarly, we open another terminal and use the SSH for router 1 to log into that. Now that we are logged into both the node and the router, we try to modify the CCNX program. In the CCNX code, we could see that the PID size was defaultly defined as 10. We modified it as 1 and tried to configure and make the binary file. Now we can see that the binary file is made. We use an FTP software called FileZilla to transfer the binary file into the node. Now we move the binary file from a temporary location to the ccnx/bin directory, where it will replace a defaultly defined binary present there. Now we try to run our application experimental client.py. We give in sufficient data to generate the metrics. We can see that metrics have been generated for the PID size as 1. Now we try to recreate this experiment with a different pit size of 1000. Displayed on the screen is the metrics for a pit size of 1000.